Hello Greatals, welcome back to another video. Still on the revision series, I am doing functions today to help you guys revise for your final exams. I hope they are still going on quite well and there are no challenges or whatsoever. But to add on to the knowledge that you already have, I've decided to treat you guys to these videos where I just help explain some last minute things that maybe you didn't get in class, just to help you guys. I wish you all the best for those who are writing maths and for other subjects as well. So without wasting any more of your time, let's get into this video. Please subscribe, leave a comment and share with your friends. So in mathematics, for the topic of functions, to be specific, we have 5 different types of functions in grade 12. So the basic ones are straight line, parabola, hyperbola, and exponential graph. But then we get introduced to the log graph when we get to grade 12, which will be the last function that I will be doing for this video. Now we are going to be looking at them. Look at the straight line. Anything that is in this manner, ax plus q, or maybe maybe 3x plus 4. Anything that is a number and x plus another one, it is a straight line. Even when you put on the x coordinates and the y coordinates, you will see that you will get a straight line. So the parabola is anything to the power of 2. So when you see an equation that has to the power of 2, it's a parabola. Even the quadratic formula, here you can see it's a quadratic formula, but it doesn't have qx. But anything to the power of 2, it's a parabola. Even when you are given a quadratic formula. The thing is that with parabola, we have 2x values. When we're trying to get x, we will make y 0, right? And when we're trying to get y, we'll make x 0. So this 2 squared means that there are 2x values for a parabola. And then a hyperbola is a over x plus p, and then there will be a q plus q as well. And then we have exponential y equals to a times b to the power of x plus q, or a b in metric to the power of x plus p plus q. This is how the formula can be written. With exponential graphs, b is greater than 0 and b is not equal to 1. And another thing you have to know, we can talk about this q. This q, it's the y value, where this graph of the straight line will cut is at C or Q. So keep that in mind, guys. And what you have to know here with a parabola is that this is a function for a parabola. This is the graph. When a is negative, this parabola is going to be a sad one, right? So this one is happy, means a is positive. When a is negative, the graph is going to face downwards. It's going to be sad, remember, with a. And then q is the y value. So q represent how many steps the graph has went up from origin. So if q is 4, then this will turn at 4 here. Or if q is negative 4, it will turn at 4 down here. So with this p, it's either the graph has shifted from where it is supposed to be, it has shifted 3 units to the left or 3 units to the right. And let's take let me just draw an equation here. Let's say y equals to x minus 2 squared plus 1. So this means that the graph has went 1 unit up from origin. This is plus 1. If it's a negative, it means it has went down, right? And then the x minus 2 means that it's going 2 places to the right, and 1 means it's going up. So right, if it's if P is negative on the equation, P will be positive on the graph. Now, if P is positive on the equation, it will be negative on the graph. So if it's a negative number for P, it means to the right. If P is negative, it's to the left. So this graph will sit something like its origin 1, 2. Then here we'll have number 2. So it will go up, and it has went 1 unit up. So this will represent the 1 here, and this is 2. It has went from origin 1, 2 to the right hand side. So that's what P and Q meant for the quadratic graph. And then let's talk about the hyperbola. So hyperbola is that one that cuts here or here. It can be this side or this side. So the Q is the y asymptote. So we will have the asymptote here. Let's try to look for equation. Yeah. So here I will take y equals to 3x minus 1 plus 4. So when we're trying to draw this graph, the equation is positive, so the graph will be somewhere in here. But firstly, let's write the asymptotes. So this is the y asymptote. So y is here. We'll take this. Let's say it's 4. We'd say y equals to 4 when you're drawing. And then P when it's positive on the equation, it's negative on the graph. And then when it's negative on the equation, it's positive. Like it's vice versa. When it's negative 1, it's positive 1 here. If it was positive 1 here, it was going to be negative 1 on the graph. So because it's negative 1 here, it's going to be a positive 1 on the graph. So this graph is going to go like this. So here x equals to 1. Sorry, if they say give the equation of the asymptote of y, you're going to say, or give the equation of the asymptotes, you're going to say y equals to 4, x equals to 1. These are the equations of the asymptotes. So bear that in mind. And also with hyperbola, we'll do domain for parabola. Domain and range. Domain represent x values, and then hyperbola represent, not hyperbola. Domain is for x values, range is for y values. Always know that. So here we have x equals to 1 and y equals to 4. So for domain, we're going to be using this one, x, which is P. So we will say x is an element of a real number. X cannot be equals to 2 because the graph will be above. Cannot be equals to 1. Sorry. So you say x is an element of a real number. You say comma. X cannot be equal to 1. So that is the domain for a hyperbola. And then a range for hyperbola is y is the element of a real number. Y cannot be equal to 4. So when you plot here your coordinates, x can never be 4, x can never be 1, and the y values you can never have 4. So it's going to be error. Basically, you're going to appear error when you put them into your calculator. Let's say you are trying to find your x values, your y values, and then for x, let's say we have x as let's try to do it here. You have a graph of y equals to a over x plus p. that is plus q. So that will be y equals to 3 over x minus 1 plus 4. So x values, and here will be the y. We have negative, we have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Those are the x values. Now we can try to look for the y values. We just substitute x here on the graph. So we have 3 over, let's start with negative 4 minus 1 plus 4. So when x is negative 4, y is positive 3.4. And then I'm showing you how to draw as well. So we are now showing you even how to draw 3.25. When x is negative 3, y is 3.25. And then let's go 2, it's 3. And then for negative 1, we have 2.5. So here we are. I also put, I did for 0, for 1 there, and it was, no. I substituted 0, and then you get 1, and then when I substitute 1, there's error. Let's do the rest. I'm going on and on. The answer, for me to get y as error for 4, it's going on for so long. I have tried so many. So this line is going to be so long. But that's where you will get your error. Right? Let's say this is the graph. And this graph cuts here for x equals to 1. And then it cuts there for y equals to 4. So I will have to find another one, but yeah, this graph will go like this. For the y values, it's just going on and on and on. I don't think it's the right example to use, but nonetheless, we should continue. So that is the domain and range for the quadratic function, which is a parabola. Now let's look at the domain of a, that is for hyperbola. Let's do the domain for a parabola. So for a parabola, the domain and range. So for a parabola, always for the domain, you can say x is element of a real number from negative infinity to positive infinity. Always you can write your domain like this for a parabola, this set or happy graph. And then for the range, we are going to look at the y turning point. You look at q. The value of q will tell you. So it can be y is the element of a real number from, here it's 1. So we'll say from positive. We are going to start where this thing is. So let me just write it like this. We can say p to, we can write it as from q to positive infinity, or from negative infinity to q. So when we look at this graph, it's 1. So we can only go up to 1 here. So anything from here going down. So this is a positive 1. So from this positive 1 going down to negative numbers, it is the range. Or if it's this one from negative 1, let's say it's a negative 1 here, a minus 1. From this negative 1 up to here. So it's going to be a negative q to positive infinity. Okay, that's what I wanted to show you guys. So here we have 1. So it will be from 1 going up to positive infinity on this one because it's plus 1. It's a happy graph. A is positive. So it's from here going high or from here going down. So look at the value of P, whether it's positive or negative. So this is how an exponential graph is. And we have here, we can say P, this P, whether it has moved left or right. So it represents whether the graph has went towards this side or towards this right, to left or right. So it works with that. And then the Q, if it has went up or down. So this can go lower or it can go upper. Okay, that is what you have to know. So let's take an example. Let's say what can I use? Y equals to 1 over 2x plus 2. So this 2, we'll just take it like this. The graph will cut at positive 2 here. And then we can only draw on top of that positive 2. So that Q serves as an asymptote this side. That's what you have to know. So another thing, yeah, this is how we do that. That's what the equation means. So let's try to let's do domain and range for exponential. And then for domain is x values. So domain for exponential is x is the element of a real number always. And then range is y is the element of a real number. And then you take this asymptote. So it's 2. So it will be from 2 going high. It's the same as a parabola. Sorry, this is 2. It will be 2 going up. If that was negative 2, maybe it was cutting here. It will be from negative 2 going high. So we will have it as 2 to positive infinity. Please leave a comment, subscribe guys if you're finding this information valuable. So let's look at how to get x and y intercept. We're going to deal with a parabola here. So to get, we are given this quadratic equation. It's also a parabola. So I will show you different kinds. Now, to get x intercept, y is goes to 0. So here, let's get x. To get x, let y be 0, b equals to 0. So we're going to say 0 equals to x squared minus 7x minus 5. And then you can use a quadratic formula where x equals to negative b plus or minus, you know it, b squared minus 4ac into 2a. So x equals to, b is this, this is a, the number is a, this is b, this is c. So this is negative into negative 7 plus or minus negative 7 squared minus 4 into 1, a is 1, and into c as well. And all of that will be over 2, 1. So here you get x equals to 7,65 or x equals to negative 0,65. So that is the 2x values. So for parabola, you need 2x values. So it will be 7,65 is to 0 and 0, negative 0,65 is to 0. So these are the 2x coordinates. To get y let x equals to 0. So y equals to 0 squared, where you see x you put 0, minus 7, 0 minus 5. So y equals to negative 5. So the coordinates of y will be 0 and negative 5. Write them down so I can show you how to draw. Then you also have to get turning points when you are given this equation. So for you to get your turning points, we will say negative b over 2a. And then from that quadratic equation of x squared minus 7x minus 5, the b is here, the a is 1 here. So we're going to have negative 7. The 7 is also negative on the formula. Over 2 into 1. So you're going to substitute, put that into your calculator, and then it will give you 3.5. So this is the x value of the turning point. Then to get the y value of the turning point, we substitute this into this original equation. So we'll say x is 3.5. Where we see x, we put 3.5 minus 5. So y value of the turning point is equals to negative 17.25. So this is the 2x coordinate, negative 0,65 and 0, and 7,65 and 0. And then we have here the coordinates 0 and 5. And then the turning points will be somewhere here, where you will have 3.5 as x and negative 17.25. So it's just down here. And then this graph will go like this, 10 here, and then end up there, like that. So we're using the turning points. These two are the turning points. So with this one, we don't have to find the turning points. This is the x turning point. This is the y turning point. So to find y, we let x be 0. So you just substitute 0 into the original equation, and then you punch this into the calculator. Y will be 0. And then to find x, y will be 0. So is 0. We have 0 plus 2 squared. We have x, sorry, not 0 here. We have x plus 2 squared minus 4. This is where you have to 0 expand this, x plus 2 minus 4. So here we are. I have expanded that. We're in grade 12, right? We have to know this. So you say x times x is x squared, x times 2 is 2x, 2 minus x is 2x, 2 times 2 is 4. Then we have x squared, 2 plus 2, that is 4x plus 4. And then we'll just take out the brackets, minus 4. So 4 minus 4 is 0. So O equals to x squared plus 4x. So there we have, we just have it like this. So here we'll have x, and then we can have plus 4. So that x equals to 0, x equals to negative 4. So these are the two x values. So for a hyperbola, this is how we find y. We let this is the equation, x be 0, then we just 2 over 0 minus 5 plus 1, and then we get to y as 0,6 when we put that into the calculator. And then to find x, so when you're here, this y goes to the other side, it will be negative 1 equals to 2 over x minus 5. And then you cross multiply, and then negative 1 will multiply x minus 5, and then it will be equals to 2. Negative 1 times x, that will be negative x. And then negative 1 times 5, that will be plus 5, equals to 2. So we'll have 5 minus 2. This 2 will come this side to be minus 2, x will come this side to be positive, and then 3 equals to x. For exponential graph, you'll be given a graph like this. 2 points is 1 and 3, and 0 and 2. The asymptote y equals to 1. This will be q. So determine the equation of the form of the graph. So y equals to abx plus 1. Q is that 1. Always look at the asymptote and just write it in the place of q, like that. And then you are going to substitute. Let's use this 2. You want x to be 0. So firstly, when you are trying to find a, use the value of the graph where x is 0. Then y equals to a times b 0. Sorry, y is 2 here plus 1. So 2 equals anything to the power of 0 is 1, right? Yeah, anything to the power of 0 is 1. So the b becomes 1. Then we just have a plus 1. So 2 minus 1, the 1 comes to the other side. Then that will be equals to a. So to get b, we are going to substitute other points. So we'll substitute this 3, 1 and 3. So we'll say 3 for x, for y equals to, we just take out the, anyway a is 1, so we'll just say 1 times b is still 1 anyway, to the 1 plus 1, and then we'll have 3 here minus the 1 equals to b to the power of 1, and then we will have 2 equals b to the power of 1 is still the same as b, so b equals to 2. The new equation will be y equals to 2 to the value of x plus 1. So that is the equation. You have determined the equation of this graph. Let's talk inverse. So inverse, it means x becomes y, y becomes x. So the inverse of those coordinates is 0 and negative 2. So x becomes y and y becomes x, and the inverse of this is 6 and 0. X was 0, now x is 6, and then y was 0, now y was 6, and now y is 0. So that is inverse. Inverse is the opposite. So let's say no, they've given you y equals to 3x plus 6, and then we are asked to determine the equation of the inverse. Y is going to be x, and then the x will be y plus 6. It doesn't end there. Y still has to be the subject of the formula, so we have to make y the subject of the formula. So another thing we can do is y has to be by itself. We can minus 6. 6 take it to this side, it will be a minus, then we say is equals to 3y. And then what I will do, I will divide both sides by 3 so that y is by itself, and then we have x minus 6 over 3 equals to y. Guys, I've uploaded previous videos on functions. You can watch them for more in-depth details. I also have an inverse function, inverse video on my channel. Please check it out. Don't forget to subscribe if you are still not satisfied with this video. It's just to go through things, just to make sure that you are ready. So with this, you will say x divided by 3. That is x over 3. Sorry, we have 1 here. So 1 divided by 3 is 1 over 3 x. Negative 6 divided by 3, that is going to give us 2, but it's going to be negative 2 equals to y. So this is the new equation. So y equals to 1 over 3x minus 2. Always know y has to be the subject of the formula. Always know that when they say they've given you a graph, and then maybe question number 3.4 or 5.4 in that question says determine the of g at x. or of let's say f at x. This -1 means the inverse. They want you to determine the equation of the inverse. Don't forget to subscribe. Remember, more videos are up on my channel. So this is a exponential graph. So an inverse of an exponential graph is a log graph, and the inverse of a log graph is an exponential graph. Know that. So we have to say x equals to 2 into y minus 4, right? And then the first thing we have to do, y has to be the subject of the formula. So we will have x minus plus the 4, it will come this side, equals to 2 to the power of y. So we can use log. So we say log 2, this 2, and then on the bracket it will be x plus 4 equals to y. So this is the new formula. If you can look, if we have log 3x minus 4, let's say, equals to y, and we want the inverse of this, that will be log 3. Here we'll have y minus 4 equals to x, and then we have to make y the subject of the formula, and then we will have y minus 4 equals to this 3 to the power of x. So this is not the end, sorry. So we will have y equals to 3 to the power of x plus 4, and this will be the equation. A log graph, it's now a exponential. For the hyperbola, y equals to x minus 1 squared minus 4. Then we make yx and xy. So x, this, the 4 will come this side, that will be plus 4, equals to y minus 1 squared. So we want to get rid of this squared. So what we do is we square root both sides. So we will be root x plus 4 equals to y minus 1. Then this will be root x plus 4. Then we'll take plus this one, it's not in the square root, equals to y. So this will be the equation of the inverse for a hyperbola. And guys, let's say two graphs meet at a point, right? So let's say maybe you have a hyperbola and an exponential graph. Here, where they say you must calculate the coordinates here, you are going to take the equation of the parabola and equate it. This is a parabola, so it's not a hyperbola. This inverse that I have just done now. Hyperbola, it's y equals to 1 over x plus 1 minus 4. So it will be x equals to 1 over y plus 1 minus 4. Then we will have x plus 4 equals to 1 over y plus 1. And when we are here, we can cross multiply. Let's see, no. Yeah, we can cross multiply. So we will have x plus 4 into y plus 1 equals to 1 when we cross multiply. So we'll divide both sides by x plus 4. We'll divide both sides by x plus 4. That will cancel. Y minus 1 equals to 1 over x plus 4. So we'll have y equals to 1 over x plus 4. It was minus, so it will be plus 1. So this is the new equation.